Welcome to Ask and Learn.
So in this problem, we're going to be working on identifying oxidizing versus reducing agents. So in order to define these terms, we're going to say that something that's an oxidizing agent gets reduced, and something that's a reducing agent gets oxidized. Another thing to remember is, what is oxidation? What is reduction? Well, oxidation is losing, reduction is gaining. Oil rig is a great way to remember this, losing or gaining electrons. So we have this equation right here. And it already looks like this is balanced for us because there's 2 nitrogens on each side and 3 oxygens on each side. We need to go through and assign charges to everything. So this oxygen gas over here is just going to have a 0 charge. When we're looking at NO, we're always going to do the oxygen first because we know that it's going to have that -2 charge when it's in this compound. And the nitrogen, therefore, is going to have a +2 charge because this is a neutral compound. Now on the right side, if we assign oxygen a -2 again, in order to define what the charge is for nitrogen, we're going to say that -2 times the 3 oxygens plus whatever the nitrogen is going to have to equal -1 because there's a -1 overall charge. So we have -6 plus x equals -1, x equals 5. So we have a +5 for the nitrogen. So the change in charges is that oxygen goes from 0 to -2 and nitrogen goes from +2 to +5. So here we gain electrons and here we lose electrons. So if oxygen is gaining electrons, it is being reduced. So oxygen is the oxidizing agent. For nitrogen, it has lost electrons. So it's being oxidized. So nitrogen is the reducing agent. Okay, for the next one, we have these. So this equation actually isn't quite balanced yet because we can see that there's 5 oxygens on the right side and only 4 on the left. So we're going to add a water to the left to add that oxygen. And now there's actually 2 hydrogens on the left, but there is 5 on the right. So we're also going to need to add 3 hydrogens on the left. So let's copy down what that would be. Okay. Now we need to start assigning charges. So we have oxygen over here. Let's do this in another color. Let's do this in this color. It's going to have a -2 charge. -2 times 4 is -8, and we need an overall -2 charge. So we're going to have a +4. Take that back, a +6 charge for the chromium. Now, copper, as just a solid, is just going to have a 0 charge. We're not going to worry about the HCO and the 3H+. Over here, within the OH, the oxygen and hydrogen is going to have a net -3 charge, and the chromium is a net +3 charge. Over here, it's going to be that +2 and -2. So we can see that the chromium went from a +6 to a +3, and copper went from 0 to +2. So chromium gained electrons, so that means that it's going to be our oxidizing agent. And copper lost electrons, so it is the reducing agent. Got one more on here, ASO4, 3 negative, plus NO2 minus, ASO2 minus, plus NO3 minus. So we have got 6 oxygens over here, 5 oxygens over here, so we're going to add 1 H2O to the right side, and we're going to have to add 2 H pluses to the left. So let's go ahead and rewrite that real quick, just so we have it balanced. And we're going to assign some charges again. Oxygen again is -2. -2 times 4 is -8, and we have a 3 minus, so we want a +5. Again, we have a -2 on the oxygen, and overall minus, so we're going to have a +3 on the nitrogen. Let's see, over on the right, we have a -2 again. That's -4. We want a -1. We're going to have a +3. And then we have -2, that's 6. So this moves to a +5. So we have AS going from +5 to +3, and nitrogen going from +3 to +5. So we have some gaining of electrons here, which means that it is the oxidizing agent, and losing electrons, making it the reducing agent.